Thank you, good student. Good student, thank you for finding time to be with me. I just want us to go through a short maybe discussion on three-dimensional geometry. First of all, I'll do just a quick introduction on the part of this geometry or geometrical figure. So we'll talk about one-dimensional and realize from this one that a geometrical figure with only length is said to be one-dimensional. A good example is line, that's a single dimensional. But those with area, that means they have length and width, you can describe them in terms of area. We refer to them as two-dimensional geometry or geometrical figure. Examples of these two-dimensional geometrical figures are like rectangles, triangles, circle, and so on and so on. But those figures with volume, we refer to them as three-dimensional figures. Good examples of these three-dimensional figures are things like cone, cuboid, cube, and so on. So these figures, they can be described in terms of volume. In other words, they have length, width, and height. So in this area, we are going to be looking at the relationship between lines and planes in three-dimensional. So I'll start with the first one, which is going to be discussing the angle between a line and a plane. So I want you to consider the plane A, B, C, and D. And this plane, I also want to consider the line PQ. If you look at this line PQ and you are to shine light on it, so the image of this line PQ is going to be QR. So QR is said to be the projection of the line PQ, that is, on the plane ABCD. Therefore, if I was to find the angle between this plane and the line, remember the projection is on the plane, and therefore to get the angle, I'll be looking at this particular angle, which is the angle between the line and the projection on the plane. So majorly what we usually do is that the angle between a line and a plane is the angle actually between the line and its projection. And remember, once you have gotten this, you can complete this one to form a right angle triangle. And therefore, you can use either the sine, the cosine, or the tangent to find that angle between that particular line and the plane, depending on the given information that is required for that case. Because if you're given maybe the hypotenuse and the opposite, then automatically you can use the sine and so on and so on. So I'm providing an example so that we can use this example to understand more. They're saying the figure shows a rectangle, tank, length 8 centimeter, width 6 centimeter, and that height is 4 centimeters. SB is the diagonal of the tank and T is the midpoint of SR. So you are required to calculate the length SB, the angle between SB and the plane CDSR, the length AT, and the angle ATD. So the figure provided looks like this, where you have the length being 8, the width is 6, and then the height is 4. You are told that SC is the diagonal, and also SB is also the diagonal of the rectangle. Remember, T is the midpoint, so this is 3, 3. So the first question is asking for us to find the length SB. Now to get SB, first of all, we need to get the length SC. And I'm extrapolating or extracting that rectangle or triangle out to have triangle SRC, this one, so that I can use it to get the length SC. And from there, you can see that this is 8 and this is 6. And I want to get the hypotenuse, which is SC. I'll use the Pythagoras theorem, as you can see here, which I'll take 8 squared plus 6 squared, which gives me 10. And therefore SC will be the square root of 10, the square root of 100, which gives you 10. Therefore, to get now the required, which is actually now SB, I'll now extract that particular triangle, and I'll end up with SC being 10, the height we are given being 4, and therefore to get BS or SB, then I'll take 4 squared plus 10 squared, which gives me 116. Therefore, SB is going to be the square root of 116, which gives us 10.77. Now, we also required to find the angle between the line SB and the plane SRCD. Now, remember, the projection of SB is actually SC. And therefore, the angle required for this case is actually this angle X, the angle between BS and its projection. Now for this case, I know the opposite is 4 and the adjacent is 10. Therefore, I am applying the tan ratio, and therefore X is equals to tan inverse of 4 over 10, which I'm getting as 21.8 degrees. Now we proceed on to the next question. The next question was asking about the length and the length AT. And to get this length AT, first of all, I have to get the length TD. That's why I want to calculate the length TD, given that SD is 8 and ST is 3. So from there, you realize that TD is hypotenuse. So I'll talk of 8 squared plus 3 squared, which I get 73. And the square root of 73 for this case is 8.544 centimeters. So TD is 8.544. Therefore, to get now my length that is required, AT, then I've already gotten this one, TD, as the square root of 73. And the other one, AD, I have it as 4. Therefore, I use again Pythagoras theorem, where I'll say AT squared equals to square root of 73 squared plus 4 squared, which equals to 89. Therefore, AT will be the square root of 89, which gives me 9.434 centimeters. Then D, you are required to find ATD, that is angle ATD, angle ATD, this angle Y here. Now remember, we have 4 here, and I have the square root of 73. So again, I'll use the tan, where the tan inverse of 4 over 73 square root, which if I do that tan inverse, I'm getting 25.09 degrees. Now we'll proceed on to the other aspect, which is actually the angle between two planes. And remember this, that the angle between two planes, what you do there is that the angle between two planes is the angle between two lines, one on each plane, which are perpendicular to the line of intersection. So if I want to find the angle between the plane ABCD and the plane AFGB, then I'm going to take one line on the ABCD and one line on the other plane, and then the angle they form in between, that is going to be the angle between the two planes. So I'm going to consider an example so that we can see how to do that particular equation. So they are saying in the figure below, PQRS is a rectangular tetrahedron of side 4 centimeters, and M is the midpoint. This M is the midpoint, meaning here is 2 and also here is 2. So from that case, they're saying show that PM equals to 2 the square root of 3. centimeters long. So I'm going to extract the triangle. I'm going to extract this particular triangle, that is PM, as you can see there, and then I bring it out here so that we can discuss about it. So realize that MS is 2 and then PS is 4. So the length is missing is the shorter side. Therefore, PM equals to 4 squared minus 2 squared, which equals to 12. And therefore, PM equals to the square root of 12. And the square root of 12 is the same as 4 times 3. The square root of 4 is 2, and then the square root of 3 remains in that. And therefore, PM equals to 2 root 3. Question number B is also asking that you calculate the angle between plane PSR and QRS. So if you look at that, I can try to highlight it again. Look at this. If I highlight this one, the plane, the angle between this plane and the angle between this particular plane. So I'm taking a line on this plane and a line on this plane, and then they are forming this triangle. So that triangle that is coming, so in short, we need this angle. We need that particular angle. But remember, this side and this side are equal, and we got them as 2 root 3 and 2 root 3. So what we are going to do here, we are going to use what we call, because the three sides are given, this side is known, and this side is known, and this side is known. So we are going to apply the cosine rule. The cosine rule is applied there. And if you reduce this, you're getting 16 is equals to 12 plus 12 minus 24 cos M. Want us to find this angle M. And if you do that, you are getting that cos M is equals to 8 over 24, which means cos M is equals to a third. And therefore, you'll do the cos inverse of this, a third. And by so doing, you're getting 70.53. That becomes the answer for that particular question. So the next question that I want us to look at is, you're told to calculate the angle between the line PQ and the plane QRS. You are told to calculate the angle between the line PQ and the plane QRS. The plane QRS. So the plane QRS and the line what? The line PQ. So if you look at the line PQ, the projection of this line is actually QM, and therefore it is forming this particular angle. So if you look at that particular angle, indeed this is the angle that we had here. We have already gotten this one as 70.53. So this angle that we need to get here is actually indeed the angle of the base angle of our isosceles triangle. So I'm going to take 180 minus 70.53 and then divided by 2. And if you do that, you are getting it as 54.74 degrees. I believe that question has enabled you to understand how those angle between plane and plane are calculated. Lastly, I want us to look at the skew lines. Remember, these are lines that do not meet. They do not meet, they are not parallel, and do not lie on the same plane. I want you to consider this plane, and I want you to consider line ML. The line ML, I can highlight it. Consider the line LM and the line PQ. The two lines are skew lines, and if you want to find the angle between them, you can actually drop this one or translate this so that this line LM become LP or becomes RQ for that case. And if you want to get the angle, you realize that the angle between them is going to be PQR, this angle here. And by look of that angle is actually 90 degrees. So skew lines are those lines that do not meet, and at sometimes they are not parallel, and also they don't lie on the same plane. To get the angle between them, translate one to the other and then get that particular angle. Be part of my class by subscribing to my YouTube channel so that you can be updated for another class. that is uploaded. Thank you.